take a look. Let's refresh. Make sure it's running. If I can, there we go. Copy video URL. Make sure my head's moving. I don't know what the delay is on the stream, but it's not paused. There it is, cool, a few seconds. Then we go red circle. I'm gonna do the whole live on YouTube thing. That needs to be bold. Hi, Dev Connor, how are you doing? I'm incredibly tired, but I'm making myself stream anyway, just to see if I can be productive. The microphone is probably going to suck. Sorry. But it is what it is. I'm using this shitty little microphone for right now because I haven't reinstalled the software for my mic on a boom over here, this direction. So it doesn't work, because of course it doesn't. Works fine on Linux without the software, can't work on Windows without it. And yes, we're back on Windows temporarily. Temporarily. I'm probably going to stick to Windows and then remote into my Linux machine, so I don't have to worry about as many hardware issues with the Linux machine, because that was a problem. That was a big problem. So, the Lexer. I need syntax. Declares me a Lexer. We put the Lexer together here. I probably want... we're working on a compiler right now. I'm basically rewriting my other compiler in C++ targeting LLVM directly. Like, we're referencing LLVM and Clang down here in our build. We're doing LLVM and Clang stuff this time. Which means I'm using a whole bunch of C++, a whole bunch of stuff I'm not entirely familiar with, but I'm familiar enough with to fuck around with. Don't save the CMake list file, please. The laptop is running Fedora. Latest stable is at 39, 40, something like that. But it has compatibility issues with my laptop's hardware and like external displays, so I stopped being able to use my double monitor setup on my laptop. Don't know what's in frame anymore. So I'm back on Windows just to get my hardware working. I'll get back into my laptop and make sure I can remote into it eventually so we can do more Linux dev while I'm still running Windows. That's about it. That's about it. I might reinstall Pop! OS on the laptop because it's a System 76 machine, so it might behave better. I never really liked Pop! OS though, so it'd be a last resort. So something I'm thinking about doing here is turning this into an implementation instead of this. I might do the same with the parser. I don't really need to, but what we're doing with the driver, for example, let me go to driver IXX, is it's just a shell, it's an interface basically that we're implementing behind the scenes with this hidden implementation here. I hate this fucking heart icon. A vector of a something. A vector of a pair. What do you mean by that? I already know what I'm going to do for the Lexer, more or less. Translating it to modern C++isms, we'll see. But what do you mean by using a vector of a pair, then use those to do lookups? For, like, keywords? So I'm just going to use a map for keywords. So if I do the private implementation here, that simplifies my interface file, which is probably a good idea. I don't really need this to be immovable if I do that. I could acquire hidden. Hidden. Am I not? Just driver. Declare hidden impl. Why isn't that showing up in my syntax? Declare hidden impl. Stood vector, stood pair, stood string, stood token kind. Why would I do that? And I don't need the diags producer or this, and then in the lexer, temporarily you get to go off to the side. I hate doing this on this kind of display, but it's fine. Yeah, unordered map is what we're going to end up with. I'm doing that in the driver even right now for this, where you're going to use LLVM's string map. I do this for extensions. Syntax here, so we have the hidden impl. We're going to want keep my brain sane. We're going to use the same formatting here with comments. If I have any internal API things, and then the actual implementation. Then, so we're in all the front-end stuff here. This is going to be lexer read tokens, which will return the vector of syntax tokens. It's not happy with me because there's errors in here now. So what I really want is, let me make sure I'm doing this in the same manner. I don't want to. So my internal API is where I do this. Where am I declaring my impl? Way down here? Yeah. So in the implementation, we're going to do struct lexer impl. This is going to be a diags producer for lexer impl. So then that means all this shit is going to go in here. Explicit impl is going to have the source file. Context is going to come out of the source file. Context then gets to be implemented not here, which should then fix those compile errors, and we should be back up and running. So we can implement context, the public API portion of context. We'll go here, auto lexer context. Something else I forget how to do is my mutex stuff, which I need to have. So I need to include mutex. I need to include, I should probably put that at the top if it's going to be in every implementation. So that means we need to text. We're going to strike the tokens in a vector. You're going to use the stream, the door. It shouldn't matter which one I do. At the moment, we're returning a vector, but yeah, I figured you didn't mean strike, but so we're going to be returning a vector for now because there's not really a reason for me to be streaming the tokens. Lexing should be fast. I'm not doing anything that needs to change what tokens were read. Right, we're not like manipulating the source. So lexer context is going to just return impl context. So then I'll want auto context, actually auto context const. Like that. Okay. So in here, when we're invoking the driver, we need a constructor that constructs the impl here. That's one thing I'm going to forget. So lexer doesn't need anything in here. It just needs to construct the lexer implementation. So that means my lexer needs this. implement it, get our implementation. Impl needs a context, that's right, so context ref context. Like that. So then when we're reading tokens, we're going to say lexer, lexer. So I mean, at this point, I don't even need a public lexer for anything other than the fact that I have this static thing. So oh, this is not happy with context because it needs a file, not a context. That's right. So maybe we don't even do this whole hidden implementation thing. Maybe we just go straight to why the hell is there a public API for the lexer? If we keep the public API for the lexer, then we should be able to instantiate the lexer on our own and read tokens from it, which is probably still fine. We want to support both. So instead, this is going to be const file, source file. So this is going to come down here to my mouse. Just jittered around like a little bitch. This gets to be source file. This gets to be source file. Like that. So then in our lexer implementation, we don't really have a way of returning the file that's being lexed right now. We can store the source file and then we can. So const file, source file. We can then do a source file via const file reference. Okay, so then go implement this lexer. Lots of drudge work to set up the interface here. Source file. Didn't save the other file, that's probably what it is. Okay. So then we'll have a way to just ask for a syntax token. And it's not going to be const, it'll return a syntax token. That's not where that goes. So then I need this exact same thing here. And to keep myself sane, we're going to implement this one outside. So we need to construct tokens. So we'll just say require to do. Implement this. So then down here, we've got a lexer. This can read tokens. This impl is not happy with me again for some reason because I'm not saving the syntax file. What type of parser will you use? Regular recursive descent like I always do. There will be one, probably still, syntax construction that requires some look ahead, like arbitrary look ahead, which sucks. I don't want to do arbitrary look ahead if I can help it. But the way that I'm doing the syntax, that's kind of unavoidable, and that will be that I'm doing C-style types int foo, right? But any identifier can be a type. I'm just used to recursive. I mean, I'm going to use a prat parser for binary, like binary operators, but regular hand-rolled recursive descent is just easy. Why do you need to do anything else? There would, like, to avoid additional memory allocations and rewinding, a different parsing methodology for the thing that I just mentioned, having like foo pointer bar be a thing. In C++, this doesn't work because this isn't a type name, but in Laie, the language we're going to be compiling here, this would have to parse and attempt to parse a declaration, and if the declaration parse fails, it rewinds and attempts to parse an expression, because we don't know if this is a type until it looks like a declaration, which sucks. Alternatively, we could try... Do you set a file size limit on source files? Technically, no, but practically, yes. I don't know. Let me go check if this file implementation has... It's using LLVM's memory buffer, so whatever the limit is on that. I think somewhere there might be a limit. Could not load file. Maybe it's in our context. Context. Let's see. Too many files. I mean, right off the rip. Not technically. Practically, yes, there is going to be a memory limitation. But loading a big file is just loading a big file. We're going to do yield something like this. Well, okay, so for that, why not have to check for a type map, then compare the type in the map if you don't have... Well, because out of order parsing. If I have... let me do this in here instead, where I've got some syntax highlighting. That's probably too big. If I have foo bar and then struct foo, well, when I'm parsing this, I have no idea what foo is. So I can for int, a keyword int, that's fine, it's predefined. Int foo, well, that's clearly a type, so we're going to parse a type and fail if it can't do that. But foo bar, we have no idea. Foo could turn into a function call, it could turn into a dot bar, it could turn into a namespace resolution, it could be anything. Until we see nothing followed by the bar, followed by a semicolon to know for sure. We could say, oh, that's a declaration, you're missing a semicolon, that's a valid error. But like the point being, we have to have something. We're not doing forward declarations, that's the point. If you don't do forward declarations, the thing I'm talking about is inevitable for this kind of syntax. I either change the syntax or I deal with the issue. Those are the only two options. Dealing with the issue is not fun, but it lets me have the pretty syntax that I like. We'll just have to be very careful to not accidentally balloon parse times near infinitely, because that is a problem that can happen. We don't want that. So, what I need in here, we have a syntax token. Our syntax token is going to need an enum struct kind. We're going to need invalid for if something bad goes wrong, end of file. For the end of file token, we're going to want a kind. We're going to want explicit syntax token to take in kind and set kind to kind. Then we're going to need a couple of other things here, but bare minimum kind. What the heck? So what we want to do is say syntax token, and then do token equals, because I think we have lexer read token is what we decided the API was, right? While token dot kind is not equal to syntax token kind end. Thank you. End of file. And tokens push back token. So then this just gets to be syntax token kind invalid. I could go ahead and say that kind equals kind invalid, so I don't have to do this. Puts it in an invalid state. So then this reads a bunch of tokens. So then if I need to remember that I'm in crazy, weird, bizarre C++ land. So every time I change one line of code, I have to rebuild to make sure I didn't break something. That's git push. I wanted test.lie. Okay, so then we hit implement lexer impl read token. Cool, so we've gone all the way through the driver. We've identified what this file is, that it exists, added it to the job, and now it's trying to parse it. In our driver, by the way, that's what we're doing. We can add a file to the driver, which will then determine what kind of file it is based on a number of different things, either the file extension or what the user has previously set as the file kind. I hate that there's so many goddamn spaces. I don't think I can do anything about it other than just watch it be there. It doesn't look like it's changing the file at all. So anyway, if it's a LIA file, it goes to the LIA build job. The LIA build job we just create one of because every LIA file goes into it. And God, I'm still tired. Whenever we run the job for each file, we add it to this syntax graph. The syntax graph is responsible for parsing the file and determining all of its dependencies, and then parsing those dependencies, giving us a graph of things to work with. For the moment, we're doing it this way because we're going to restrict cyclic references through files. Each module, each file, is only going to be allowed to reference other things, but never back to itself. Eventually, I'd like to resolve cyclic module references and do that at the declaration level, but that's a lot of extra work for right now. So we're going to build the graph, make sure it's an acyclic graph of dependencies, and then we can shunt it over to semantic analysis later. But that way we can do, we can order the semantic analysis by like depth first with a topological sort. I don't know if those actually end up with the same results, but you know. So that add file call here is going to give us parser parse. Parser parse is going to call lexer read tokens. Lexer read tokens is going to read all the tokens. That's how we get here. So once we're done reading tokens, we'll hit one of the asserts here for actually parsing the tokens. Parsing the whatever from the tokens. Anyway, so back in syntax, we have our syntax node here. It's going to need a location, our syntax kind here. Location. I'm pretty sure this is the one we want. It has a position, a length, and a file ID. Lots of things in here, lots of things in here. Okay, so then to man with 1,000 names, this, I guess, is technically where our file size matters. If we can only index a 4 GB file, then that's all we got. And it looks like the reason we're doing it this way is because somebody wants us to be able to encode and decode from a 64-bit number. So practically, if we're using this source location methodology, we get 4 GB files. Which is doable. We get 65,000 files. So I'll have to ask him why we care about encoding and decoding from a 64-bit number. Yeah, I mean, 4 GB is going to be a massive file, so I'm not worried about it right now. If ever somebody wants to, like, generate a bunch of files, they're going to have to either create it or turn it into modules that reference each other or put up with it. So we'll use, why does this file never want to save? What am I doing wrong? So we've got a location. Token kind is token kind invalid. Location can just be an empty location by default, but if we pass it, we get a location. From the location, we can get the source. I doubt this has encode is valid, seek line to column. Interesting. Well, I forget what location info does. It's a line. Okay, so that gives us line and column information, which has a line start and a line end. That's cool. Okay. I like that. I like that. Text. Yeah, so location gives us the string ref to the text. So I can actually just, one step removed from that, auto text const should be return location text question mark. Text needs to be in a context probably, I think is what it said. Text in, I think I can do const context ref context. I'm not reading my shit well enough. So that should return a string ref. I like to be explicit about my type returns when I can be. And that's an LLVM string ref. Okay. So our token does that. We don't have to store the text anywhere. We have the kind of the location. I don't know if I'm going to bother parsing very many things here. Normally when I write a lexer, I parse all of the integers and floats. Especially strings. I can almost certainly do string parsing in here, but integers and floats, I guess I can do. I always get frustrated that I don't have access to arbitrary precision integers in C++ or in C. But we're in C++. If I don't have access to one, I can probably find one really easy. For example, I think, is it in utils or core? Yeah, there's an AP int. Does AP int come from LLVM? 80 AP int. Okay, LLVM gives us an arbitrary precision integer. God damn. AP int. Beautiful. Now, do they have something float related? AP float. We probably want AP int and AP float. And for allocating string literals, we're going to use the string saver, which should give us a string ref. So for now, we could say AP int. Actually, hold on. How does this one? What is this? What I'm looking at here is another compiler from friend of the channel, Sarade. So he's got integer storage, which has a vector of ints that we've saved. So we can store an int and get back our stored integer. Our stored integer is either the data or a pointer to an AP int, which is stored. Is inline, stringify it. I might use this same system as well. Get the value of this integer in context of storage. So, interesting. So if I go to utils cc, stored integer cc, what is this implemented as? If the bit width is less than or equal to 64, get 0 extended value. Otherwise, save it, size. Okay, that's easy. Inline value, like this. And we can do the exact same thing for the float version. if I go learn how the float works. So let me take this whole gabagoo into core.iix. And we'll put it right above color stuff. There's a file. There's a size. We like size. There's a string. Put at the end of string here. So we have a stored integer with internal storage. We have a small vector, which needs to be an LLVM small vector of LLVM AP int, which might even need to include float later. Get down there, god damn it. LLVM AP int I int64t int64t LLVM p int. Okay, so then we can go into here and say stored integer cdp, which just needs to have a lot of the same going on up here. Specifically, we just need the AP int, I think. That. So we're going to be in choir. Then here again we need LLVM's AP int. I need to reconfigure so that it gets IntelliSense back. To build sometime soon. I64 is int64t. LLVM2 string needs to come from somewhere. That's in string extras. Include print. We'll see if that works on MSVC. I might have to do that. Let me get my chat back. This is size t. This is uint32t. This is LLVM int. And if we build, does it fail? Cherry Coke. Not the healthy. Okay. Oh. I'm almost out of water. That is part of our problem. We'll figure that out in just a second. This way I can parse all my stuffs in the Lexer. We'll need to find a place to put the integer storage. Probably in the context, so that would make enough sense. Rebuild succeeded, okay. So that gives us that. Let's, if I go to context, I have a context, driver have this, storage, context, no, core context has, I'll need that eventually. Interesting. Where do we use integer storage? Because I'm going to put it in my context if I can. It's in the parser. Allocator used for integer literals. But we need it in at least Sema and or CodeGen. So where does this get integer storage? Does it just exist? Sorry, I'm looking at this code again. Because some of this is not mine, making sure I'm using it kind of sanely. This is where integer storage is in the source, as well as the string allocator for strings, which makes sense because the lexer and the parser are responsible for this. But where the hell do they get saved to? In the module, that's where. Okay, that makes sense then. So each module individually has its integer literal storage and its string storage. That makes more sense. I think I like that. I think we can do that. So that puts us back in syntax. We have this module here, which needs this, which means I need a bump pointer allocator. Not here, support. I guess we just go allocator, support allocator. Okay. We have the bump pointer allocator for that. We have integers for that. Then I guess they're just gonna, they're in the public here, which isn't terrible, actually. Fuck it. I'll do the same. Why does it keep wanting to not save and then save to this? What is the problem? What is the problem? I don't know. Okay. Now this is unhappy. Why? What did I do? Is that bad? Do I need to restart Visual Studio? Hello? Build? What did I do? What the heck? What the heck? I'm killing Biz. We're starting over. Choir. I don't like that I have to work in Visual Studio, but I do. Integer storage. Generation finished. Build. Missing type specifier, int assumed. C++ does not support default int. But it's a class. Unknown override specifier, integer storage. I'll get it. Do you want this to be choir integer storage? No, you don't. What? What if I do this? Now what? What do you want from me? So much here. That works. Why are you unhappy with a class name? What? Because I didn't put it up here? Probably that's why, if I had to guess. Build. That looks like it's working this time. And it's still going to give me the Lexer. Cool. Read token. All right, so now our module is where we're putting this storage stuff. I'm now curious. If we go back into core IXX here, then, I mean, we've got integer storage here, and a stored integer. I want to know more about floats. None of this is implemented in here, so I can't do a whole lot with it. Can I, hold on. if I can do LLVM, see if there's a document. Oh my god. DuckDuckGo.com. Question mark. Then LLVM AP float. Class reference. Do I have a way to check? What is that? I don't know. Is IEEE is probably what I want. Does it fit in something? So, no, I don't want that. I probably don't need to worry about this right now. Return uses layout IEEE float. What does get semantics return? Bit semantics. Is this the one that I want? Size in bits, probably? Because I can probably use this. So then maybe fit semantics has... I mean, if is a float. Ah, see. If uses layout double AP float, turn double method call. So IEEE here means single float. Unexpected semantics. Bit non-finite behavior. Bit semantics. Oh, you've seen that. Okay, so we can check against actually predefined semantics. That's good. Enum to semantics. That'll be good as well. Semantics back to enum. Okay, so we could do a similar thing for floats. Very easily, well, less easily than we could for integers. So I might... Let's come down here and attempt. So if I say we need... float storage and a stored float. We can grab float. Okay, so then we can store float, which will return a stored float. Easy enough. So, a stored float. I'm gonna go create a... That takes too long. Storage float CPP. Copy stored integer. Store float. Like that. We'll do everything else later. So, in order to store a float, so this is a float. we need to define what SF is soon, or we're not going to get compiled. So a stored float could do the same thing, but instead of storing bits, we can store its semantics. Do we have semantics for does not fit? Like, what is bogus? Where do we use bogus for? Number of bits actually used in the semantics, right? So I can do that. I can just store... I can store the fit semantics as the enum here. No, I keep calling them fit semantics. It's float semantics, but semantics. AP float based semantics. So I can store this. What are all of my available values? Max semantics, double extended, half float, single, double, quad. A B float is the other one. Max semantics. But I don't have an option for none of the above. How does Clang use this shit? I know this isn't the most interesting part, but I'm curious now. There's lots in here. So I'll probably implement the float storage separately off camera. Let me reconfigure anyway so we can get a good build going. But it's good to know that this should be relatively doable. Don't know why that keeps happening either. Build, and then we'll go implement the Lexer. So SF uses undefined class, that's correct. It needs to return a stored float, so instead it can acquire do like that, which should then not complain anymore. Oh, because it returns an incomplete type. You know, that'll do it. We'll just get rid of it then. Okay, because we're not using it for anything right now. So back in syntax and Lexer, we have our integer storage, which will eventually also include a float storage. We have our string allocator, so we can put things wherever we need the things. So next problem. I say problem. The Lexer doesn't know anything about any of this like it should. So my API needs to change slightly. I can't just call Lexer read tokens because we don't have either of these allocators to allocate into. So, God, I'm so tired. I might have to take a break and make myself walk around or something. Make tea, I can do a soding and I can go make tea and come back. Tea will take time though, it's like a 20-minute tea steep for me. Where do I want to put these? I could put them in the Lexer. And we could say, hey, if you're doing this, you don't care about this. But if you're constructing the Lexer by hand, but then I have to rewrite this for the parser. So I don't like that either. Right, because what I'm suggesting is we want this in the module, but we might also want it in the parser. And it might be a feasible situation for the parser as well. But currently my parser's got stuff, but we just moved the Lexer to be a hidden implementation. So we might move these into and out of where we need them. Right, this is a unique pointer. But maybe we just make it a shared pointer. Or we could pass it around by reference. Or a weak pointer. Can you turn a unique pointer into a weak pointer? I don't remember how most of these pointers work, honestly. We could try that. So the module would be, but then if you're reading, so I might really have to change my entire API here to not expose a Lexer in the same fashion if I want this storage here. Because what's happening right now is when we construct a parser, we're also constructing the module, and that'll be where all the storage happens. So if we call Lexer read tokens without a module, then, oops. So if we instead say that we always have to construct a module, then we can Lex into the module. Because then I can say, instead of returning a std vector of tokens, I can just say std vector of tokens here. Right. So then we can go into the tokens. Why it gotta be like that? So then we can change the API, and instead of taking a const file, because this has a file now, right? I can say source file is a const file ref, which we just return goddamn source file. I can then make this also private, and then we could say auto tokens const std span of syntax token, which I think would have to be const as well. So std span of const syntax token, return tokens, question mark, is that, do I need to include span? Vector for sure, span, question mark. That looks happy again. And then if I want to be able to modify it, non-const would return std vector reference. And I could push into those tokens. Right. So then here we would take a syntax module reference. Syntax module. So then tokens here, well, we don't return tokens anymore. We just void. Then we say this tokens push back that token. And we don't return anything. So then read tokens, syntax module. Have you ever thought of moving off LLVM? I just moved onto LLVM this week. The biggest reason for moving on to LLVM is just having a shit time in my middle and back end of my last compiler. So we're giving it a shot. And moving into LLVM, which is why we're at the Lexer stage. We're just starting. I have previously Let me go find Nashira. Fucking, nope, that's why I can't find it. I have previously written a couple of compilers, but this is the most recent one, which is just in vanilla C. We're still targeting LLVM through the text IR instead. Then it had an in-progress C backend. But if I go to here, there's a C backend and the LLVM backend. So we were just writing LLVM IR as text. I don't want to be on LLVM forever, but it is very convenient when you have it set up to get all of its tools for free. But I've been trying to not use LLVM for forever, and it just became a pain for the things I wanted to do. Because, I mean, writing your own custom backend is it's just a pain. It's just hard to do. You can do some really trivial stuff pretty easily, but I didn't want to write like a register allocator and an assembler and an object file backend. I could put up with writing a C backend, but then you got to deal with the semantics of C. So it was only ever going to half work. And I want this language to seamlessly interact with C and eventually C++. I've considered Cube. I haven't heard of Tilde. I've considered Cube. Cube is like fine. I didn't like the project structure. The IR looked passable. It was fine. It wasn't exactly what I wanted, but it was fine. But trying to use it, I didn't want to have to write another textual backend. But the only way to use Cube was to generate a text file and call the Cube executable. You couldn't use it as a library. So I was just going to be doing the exact same thing as LLVM, but right, it just felt very strange. If Cube could be consumed as a library, I would have done that months ago, years ago if I knew about it, but months ago I would have been using Cube just for ease of use. I might still use it eventually because I still want to bootstrap this compiler. Zig and Odin are working on a new thing together, very early stages. I hate that ungoogled Chromium doesn't even give you a default search thing. I have to DuckDuckGo it. I need to learn how to use this stupid search bar. Because I want to build eventually something similar to LLVM alternative, which is what I was doing in the C version of the compiler here. I just didn't want to write all those backends to get my compiler working right away. Is it this? It's a very strange word to search for. This doesn't really... Yeah, the GitHub repo. There we go. Is it this one? That's something entirely different. This is... Is TB the tilde backend? And quick is the front end? If it's in early stages, I'm not going to use it right now, but this might be a valid thing I use for the Bootstrap compiler. Yeah, if it's part of quick, then I'll look into this. We're going to stick with the LLVM thing for right now. I still want to build my own LLVM-free compiler eventually. It just got to the point where I was so burnt out trying to do all the things I needed to do that I was making no progress. I have basically not worked on the language at all since March. I tried to for March, April, May, and it basically didn't happen. June, July were completely silent, more or less. So I've just been burnt out trying to do all the stuff I didn't want to do. I'll do them eventually because I do want to do them. But at the time, no. I just... We're trying to revitalize my wanting to finish this language by going to something that's going to handle the shit that I was stuck on. So let me go to something I'm actually logged into. I'll give it a follow. I'll give it a star. Sure, regular ass watch. So what is this? This is part of Quick, but I don't know what the TB backend looks like. Tilde backend in the form of a reasonable C library. Yep, that's what I was trying to build, but kind of fucked it up. File export functionality. Elf and cough. PE and not go. We got to explore. Interesting, they're going to build in a linker. That's fine, so long as it works on all the necessary targets properly, because that's the one problem with linkers, is knowing where the fuck everything is for system libraries and shit. Like, replacing the linker on Windows probably isn't a big deal, save for the fact that you have no idea where anything is, because they expect you to be running things from, I guess, yeah, if you expect people to use the native command prompt from Visual Studio, you can rely on the paths being set there, probably, but if it's an alternative to MSVC, I would love to not have to install MSVC, but you kind of have to get the development libraries. Windows is hell. Windows is hell. So I will keep that in mind. I'll keep that open because that'll be cool. Do you have any good resources for using LLVM in the background? How do you want to use LLVM? Zig includes their own linker. Do they at this point? Have they actually done that yet, or are they still just calling Clang? Because like half of Zig is just Clang, which is, to be fair, exactly what I'm doing. But I haven't looked at Zig in a while, so I don't know. Because Connor, if you're asking how to use LLVM the way I'm using LLVM here, it's very painfully. I am writing up build documentation right now for code generation. Do you want to consume LLVM as a library, or do you want to generate textual IR, or are you just talking about the concept of generating IR in the first place, regardless of LLVM? Like a little bit more context, what you want would be nice. So then my lecture. Now I'm completely forgetful how to get the, I think it's just file.begin is what I'm looking for. Where is the constructor? It's in the CC. I'm in the CC. Because I wanted this current and end. Current, where do I set current to? Here. Okay, so it is data and data plus size. That's what I'm looking for. Okay. So in our lecture CPP, we have begin and end, but I really should have just current and end. So then when I do this, we're going to say, so these don't need underscores because they're not private, which then means I don't need this. It's the impl. We can be a little bit more sketchy. So current is going to become source file data, and end is going to be source file data plus source file end. Not source file end, but file size. I was like, what the fuck am I typing? Doing some math work at the moment. So I have a tree, yep, and I have the type checking, yep. So now I have to do code generation or IR generation, so I don't. I hate this little heart. And I don't really, that was just the end, okay, couldn't tell. If you've got anything else to say, I'll wait for a second and then I'll try to answer. So how could I use LLVM to do the IR generation, then leave that in the code generation? But if you're using LLVM, LLVM will handle code generation for you. That's the beauty of it, right? Your code generation stage is then just LLVM IR generation. You can, do I have Lia open still? don't. Can I open a new one here? CD tab, YA code. I mean, what you're gonna want to do is you're just gonna basically want to walk your tree and generate your IR. So my IR gen is going to my own internal IR in this compiler here. Again, it's going to depend on if you want to use LLVM as a library or if you want to generate textual IR. I'm going to show you if you're using something as a library first and then generating the IR second. So in here, my IR gen for my C version of this compiler is, it's just walking a tree. Somewhere in here, I'm going to, where the hell is just IR gen? So I've got a context here basically, which just has some information about the IR I'm generating. And where's my entry point? But basically, I'm just going to walk through. I want to generate IR for a declaration. Here's my context. Here's the module I'm generating from. And here's the node that's the declaration that I want to generate. Do stuff. If it's a function declaration, I'm going to go through and let's see, where am I creating? This is all of my linkage options. All of my parameters get generated into IR values by just saying fucking... Where am I creating any of this stuff? Node decal, function type, parameter type, get an index, function type. So I had to get the IR function type. So I built the type of the function up here by just calling this function. I don't know. It's not easy to point out what any of this is if you don't know what any of this is. But at the end of the day, I create a function. And this is an in-memory IR function, which has all of the information about its parameters, the type of the function, the name, the linkage, is it external, is it internal, re-exported, whatever the fuck. And I can store that into my IR gen. Easy peasy. Just consuming it as a library, you're just going to walk your tree and construct whatever is necessary for that node. So a function declaration, pretty easy. If I go generate for... This is converting types. If I see the type void, I return the IR type void. If I see bool, I turn the int type with 1 bit, right? If I see a function, I go through every parameter and I convert its whatever. All of its parameter types get converted into the IR. Into the IR types, etc. If I see an array, I convert the type of the element and I do constant evaluation if I need to get the length of the array. If it's a struct, I do the same thing for every field, right? You just, for every possible option you have in your AST that you've type checked, do something. If I want to generate a node that is not a declaration, we can say, look, if I'm generating, what's an easy one to look at here? For is not easy. I had to do steps there. While is easier, but still not easy. If I want to return a value, we're going to return void if there is no value. IR build return void. Cool. If I want to return a value, I generate the node recursively for my tree, a tree walker here, and then I return the value. LLVM works very similar to what I've got here. You're just going to learn the API, walk your tree, generate the right stuff. You can reference this code. It's on GitHub if you want it. My GitHub is in the description, but this is going to be at the Layelang repository instead. So if you need it, there's a send button there. You can go fucking check out this, see if you understand it, ask questions in my Discord, which is linked description if you want to. Lots of smart people there. If you want to generate text, you do a very, very similar thing, but instead of calling these functions, you just write the text to a file or something. So if I go to lyre, minimize all this shit, lyre, lib, LLVM here, this is where I take that IR that I built in the previous step that I'm very hard to explain aside from I literally just do it. And we generate LLVM IR. And I just have functions for printing the header of the file, printing a type of a struct, printing the name of a global and its value, printing a type, Print type is pretty straightforward. If it's a pointer, we print 3 characters, PTR. Wow. If it's void, it's void. If it's an integer, we print I plus the width of the integer, which I have in the IR. So you could do that straight from your AST instead of the intermediate check here. If it's an array, it prints the element type first, and then it formats an open bracket and a closed bracket with the size times the length, right? Like it just, I learned the syntax for LLVM by Googling it, or export. You can just run Clang, export LLVM, and read it to see what it's doing. If you do like Clang, I think it's S emit LLVM, right? So if I cd to choir and then a Clang S emit LLVM test.c test ll, and then we can cat test ll. Cat doesn't exist on here, right? Code test ll. Well, we're not generating its bitcode format, we're generating its textual format, right? We're generating this stuff. This stuff is pretty easy. LLVM calls, it depends on how you reference LLVM. The way that Choir is doing it right now, we're building LLVM from source, which takes a long-ass time and is not super feasible for most people. You can reference its libraries directly, but it's not something I'm currently recommending doing because you get a lot of things for free by referencing their CMake files, right? Like I'm over here looking for the package for LLVM and using some calls from it, like add Clang executable, or setting these values for things for LLVM to reference. Because add LLVM, actually, we're including add LLVM, but we're not like using it. So maybe I can try removing all the CMake stuff and provide a. I wanted to anyway. I wanted to remove the reliance on LLVM's CMake to see if I could do that. But using LLVM as a C++ library is what I'm going to be doing. It's the most correct way to use LLVM for getting all of its features. Saw a lecture today from the creator of the Rock language, and he was talking about how much better it was to generate LLVM bitcode instead of calling the functions from Rust. Yeah, because the other thing that happens, right, the most complete way to use LLVM as a library is through C++, either like this or manually figuring it out yourself. The other way is through the C API, which is incomplete and not updated very often. They will just not add things to the C API. And most things use the C API because you can reliably call C functions. So even in Rust, which uses LLVM, they're going to be providing you bindings to the LLVM C API, which does not have everything and is not complete or updated to the state of the C++ API. So if you want to use the LLVM API from a language like C, I would recommend you just use C++. Otherwise, yes, generate the IR or the bitcode manually. Because using the C API will work, it's just not perfect. It's not even that good. Yeah. So that's why this compiler that I was showing off earlier is generating textual IR, because it's the easiest thing to reason about. It's really easy to look at the generated code and understand, but I'm not having to consume it as a library through the C API, because it's just not good. But we're linking with LLVM in a C++ land to try to use both LLVM and Clang as a library, because one of the features of this language that I'm building is I need to be able to say, let me just go to a test file here, this one. One of the first things I'm going to be testing as soon as I get this lecture and parser up is imports.io.h. This is a feature that I want this language to have, and while I want to write a C parser, and I have started to in the past, I'd rather just have Clang handle all of the platform-specific nonsense, all of the extensions, all of the everything that's fucking stupid about the world for the time being. So I'm going to see, hey, imports.io, we're importing a C header file. I'm going to add that to a temporary buffer. This is going to get translated to include stdio.h. And for every write stdlib, stdint, I don't really need stdint, but like I'm going to append all of these to a text buffer and pass them off to Clang as a library to get back the AST type checked for the result of all of these headers, and then automatically generate bindings so that I can just then say printf without having to write, automatic FFI bindings by using Clang, the Clang C and C++ front end. That's the idea here. I was already going to do this just manually with my own C parser, and that was going to take too long to get everything I wanted. So this is going to happen soonish. I'm already linking against Clang. I've already tested that I can filter the AST down to just declarations, and I can do transformations on it. So that's the idea. Auto FFI. So the idea is when you're using the Quire compiler, it's going to behave similar to any other C compiler, and it's going to delegate its work to Clang as a library if possible. And if it can't delegate it to Clang, it's going to just call Clang if it's installed. So Quire test.c is just going to turn the command into Clang test.c. But if I say Clang test.lyik, which includes stdio.h, that's going to stay a Quire call, and it's going to build in the library source code this, well, what I said earlier, and give us a and it's going to give us an AST. And I have my experiment code still in here. So if I looked at example here, so this is the kind of thing that we're going to be doing. I can grab an entire type-checked AST unit by calling Clang tooling build AST from code. So we can generate an include statement and whatever else, right? And it will give us a whole thing we can iterate over. So once I've got all my context stuff, I can even generate LLVM IR off of that. But all I was doing here is dumping the entire translation unit to text so you can view it. And we also had a way to iterate over the translation unit decal and filter to only declarations. And I don't know where I put that, because I was moving things around. I might not have saved that one. Running the driver, driver.cc. Here. So in this one, I got it from the test.c file that I had on disk a second ago, but I don't think I've showed you. Still building the AST and getting the context and whatever, but I can just iterate through every declaration in the translation unit, and I can start doing things to this. So for every function declaration, I generate the equivalent of, that's the wrong file. You can still do it in Lya. It would be, I don't have, it would be foreign, like printf, just in case the name is different. Call conv cdecal, I think is my syntax for it. I32 printf, I8 buffer, which eventually should probably be null terminated or something like Zig does for format. And then it had a var args, right? It would turn printf into this declaration just through the import here is what this is going to be doing. Go through, read a function declaration, generate the equivalent of this code behind the scenes. Now you've got CFFI for free. Languages like Zig, which have a similar feature from my experience, have a problem mapping C types to Zig ones. You can't use C macros in your code. I was trying to solve the C macro problem. It's possible, but not ideal. I actually have an experiment I was doing in C# to make my life not hell for testing this, where I made a C preprocessor shell, which is not fully implemented yet, that is implemented in terms of tokens. Let me make this bigger, close this, close this. I had a preprocessor which took in the type of token and type of lexer, and it would read token by token through your lexer here. And a lexer would have to be able to say, hey, is this a valid preprocessor identifier character, etc., etc. So I was going to actually implement a preprocessor in terms of different lexer types and different syntax so that you could preprocess your own language and consume preprocessors from other languages. That is like a step too far. I don't think that's actually going to work how I want, so we're not doing that. But the other step is, if I go back in here, somewhere in here, we also have access to I think it's AST unit preprocessor. No, AST context. No. Somewhere in one of these things, we have access to the preprocessor. Yeah, so we can, from the AST unit itself, we can get the preprocessor and we can start looking up. We can get a macro definition from a string, from an identifier. So while you can't use all C macros in Laie, we can at least try. Because if you have a macro that just turns out to be a valid mathematical expression, which a lot of macros are, we can do that. We can just attempt to say, give me all the tokens for this macro. We'll attempt to turn them into Laie tokens, and we'll attempt to parse them as a Laie expression. And that will be maybe functional somewhere. How would you model C macros in your own language? I'm not planning to. Is it a function call? Or the arguments have types? Does your language have a macro system? Does it map to the one in C? It's going to have C++ style templates, but not as fucking weird, ideally. The reason I'm talking about expanding macros is because you might be able to say, like, at W if exit, right, or something, on whatever. I don't know what the syntax would be for it yet, but if I allowed you to use preprocessor stuff, you'd have to opt into it. I also considered like impulse C, and then everything in here gets switched over to a C parser, which would mean we don't want to parse an entire array of tokens. We would want to read token by token, which is why the API is still going to allow it in case I switch to a system like this. Because then I could say W if exited, and it would use a C parser instead. But lots of options. I don't know what the right answer is going to be just yet. But if I go back to here, we're going to have templates, like templates. I don't think I'm going to stick to this syntax. I'm probably going to go to template this, like this, and then that'll be what it looks like instead. Many C libraries make heavy use of macros for their public API. Yes, which is why I still want to support it in some way. I just don't know how I'm going to do it yet. You're not wrong. I'm well aware of that fact. I'm a C programmer myself. I wouldn't have written an entire compiler in C if I wasn't. Forget the fact that I'm temporarily or permanently dropping the compiler, but I have written a lot of C. I know. I have consumed a lot of C. I know how it works. So I'm going to, it's a problem I want to solve. I just don't know the right way to solve it, because if I solve it too aggressively, I might not make a good solution. But if I solve it too conservatively, it might not be useful at all. If I can find a nice solution, I will. The hope is that I'm not dealing with libraries that are like, if I have like int foo impl, and I have define foo, and then I just foo impl, like that's easy. That's easy enough. These are the kinds of things that should parse just fine in Laie and in C. So if I have some syntax for calling a macro, this will work. If I have to start taking in complicated arguments, then maybe not. But the same would work here. If it's just foo impl, and then it doesn't matter what comes after it, it's just going to be a call. Then, like, I can't off the top of my head right now think of the kinds of cases that would be a problem. I could construct them with a little bit of thought, but brain. Point being, it's in the back of my head. I'm thinking about how to do it. I don't have a perfect solution yet. The closest solution I have is either using that at syntax or something similar that I was talking about, at foo, which would then turn into just foo impl. The problem with function style macros is I have to turn laye tokens into C tokens again, which is fine because I'm going to be turning C tokens into laye tokens anyway. So at foo barbaz something, I don't know, less than. I'd have to take all of these laye tokens, convert them into C tokens, give them to the macro to expand. So I know that I can look up definitions in here. I don't know if I can like trigger an expansion. I can lex an unexpanded token from the preprocessor, for example. So if I get definition again, I'll have to figure out how to tell the preprocessor to expand things, right? Get macro definition, get... Right. I need to go look at the API more, basically. Hello, Sarade. We're talking about stuff. We got on a side tangent of all the things that we're using LLVM and Clang for, and now we're talking about the preprocessor. You think such a tight integration with C would hinder your language's ability for future development? Kind of, but also no. Like I said, I don't want to overcommit to having the language syntactically integrate with C. And there's still plenty of ways to build on top of C. Like C++ can mostly consume C, and it's a wildly different language. So as long as you don't do absolutely crazy, stupid stuff, you shouldn't lock in most of your design. That's not a great example, don't get me wrong, but C is very easy to consume. I'd like to make the process of using C easier because everybody's going to do it. Whatever language you've got, they're going to want to bind to C. There are bindings to C for everything in every language. So I just want to make that process easier. Worst case scenario, if I can't get the macros working how I want, you can still just call what the macro does and write your own wrapper around that, right? So if we had that issue with foo impl, right? If we had our int foo impl and I can't get you access to foo impl through foo exactly how I want, you can still just do this, right? Did I make it an int? I did. You can still just manually do it yourself in the meantime while I figure it out. I don't have to solve the problem right away. I can release 1.0 with just the header include feature and call it good. And we can do research onto how the hell to do the other more complicated stuff later. I'm not too worried about it. Worst case scenario, it's a language that has slightly more features than other things and doesn't live up to my own expectations. Best case scenario, it's useful, right? Hell of a lot more useful than manually writing bindings or calling another tool to write bindings for you. So at the end of the day, to me, that's still a win. That's a hell of a lot better than nothing. So, to your credit, no one has solved this one. Yeah. To my credit, that's why I'm not committing to anything big. I'm not committing to, I'm going to solve the problem. I'm committing to, I'm going to experiment with the problem and see what I figure out. And that experimentation is why we're linking statically with, or maybe not statically, I don't actually know what, if they're libs, it should be statically. That experimentation is why we're so directly linking to LLVM and Clang. Because if we don't, it makes that experiment much more difficult. Okay, so down here, we need to parse. So, new problem, not really problem, but I need to change the parser constructor to not take in the tokens. Right. What we're going to do instead is tokens Lexer, let me grab it from parser CPP. Lexer read tokens. So tokens is Lexer read tokens of module. Do I deref the module to get a reference to it? So this is a step move. Is also the next thing I want to do here, but read tokens. Oh, because read tokens is reading them into the module. That's right. So Lexer read tokens module. We then don't need a tokens here. We need auto tokens const split span const syntax token return module tokens, which is doing the same thing. God damn it. Okay, so now that Sarade is here, he can tell me the correct way to do what I'm doing here. If this is a unique pointer to a module, this sounds sketchy, like I shouldn't be doing it. I shouldn't be making unique and then returning a reference to, I guess I can. That feels weird. But, and then parser returning the unique pointer, I guess means I have to move the unique. What does yours do? What is this API supposed to look like? Am I doing the API correctly? Where is parser.cc? Where is parser parse? It returns move. Okay. So I don't know if I'm doing that yet. Looks about right to me. Okay. Because then in parse here, I just need to remember to return parser std move parser module. That. Okay. So read tokens into a module. We're required to use a module. This is one of the few instances you have to return std_move. Yeah. Yep. Yeah, the thing I was more question is, if my API is read tokens module ref, but my parser has a unique pointer, am I okay to do star module to get a reference to the underlying module in the unique pointer? I don't think that's a problem, but I don't know semantics of unique pointer. I assume it's fine because it's just a reference and I can't do anything with the reference. So now my impl doesn't have a context anymore? It does, but it's not a function, that's why. That's fine. The main thing is to make sure that none of the references outlive the unique pointer. Yeah, which they shouldn't. It's happening by the end of this function call, it's gone. We're reading tokens and then just discarding it. Right. That makes sense. So then our Lexer impl now just needs to read tokens. We have current, we have end. We're gonna need a bit more state than that. Oh, hey, also, while you're here, Sarade, I know you don't do floats in your compilers very often because you don't need them to write the compiler. But I was going to create an alternative to your stored integer for floats because I do floats. No matter how stupid they are, I do floats. So I was going to mimic as best I could your integer storage here, your stored integer for floats, which I think AP float is the right thing to use. I'd say, yeah. I'm using AP float. I think I understand the API enough from reading through it here and in source code. You type that out while I see what the hell this notification is. Duolingo wants to kill my family. It's because AST nodes can't have destructors, which is also why Clang does. Okay. I mean, that's probably fine. I don't intend for any of my syntax nodes to need destructors either. So I'm probably doing it for the exact same reason as well. Because I want the context to own basically everything that lives long. Which in this case, it's not technically, because the module owns the syntax, right? Because we've both got it in our modules here. I'm probably going to see if I can move this stuff out into the context instead. But for right now, it's at the module level. So the lexer and parser can allocate stuff, but then I'll have to move it out somewhere in Sema. AST nodes can't store a vector or small vector. That's a good point. So wait, right, the p-impl can't do that, but yeah, so that's unrelated. So if we can't store a vector or small vector, what do you do instead then? Wait, I've never looked at your actual syntax tree in here. What the hell are you doing instead? Yeah, sure. Start explaining while I read. Tiny pointer vector. That's fair. Let me get my headphones on. We can do this. I'll have to turn your mic on. Oh my god, so many Discord notifications. How do you do the bullet points in MSE again? Hold on. Great success, cool. What's going on with the pinging here? Okay. General chat. Boom. Okay. OBS, turn on my, hello. I think desktop audio is good.
I don't know if it is on stream.
It looks fine in OBS, but that doesn't mean anything. So if anybody says you're quiet, we'll fix it.
All right. Maybe you could share your screen because your stream is probably behind.
It's about 5 seconds for me, so it's probably worse for you.
Yeah.
Okay, I'm looking at your code here. I don't have LLVM up.
That's the wrong thing to look at. We need to go down further. No, it's the right file, but we need to scroll down. Let's take a look at like a call expression or something.
There's a built-in call.
For instance, that works. So the way it works in Clang is that we don't allow AST nodes to have the destructors, and the reason for that is because they're allocated in an arena, but it's all freed at once.
Yep.
So no destructors ever called because we don't even know how to get to the individual objects in the arena because they have different sizes and whatnot. So how do you do that then if you want to, for instance, store extra data dynamically in your node? Like if you have a call expression that has 7 arguments, how the hell are you supposed to store them? you allocate them afterwards is the answer.
Yep.
As trailing data, a bit like flexible array members in C, and there's an entire API in LLVM for that called trailing objects. And the way you typically use that is it also works a bit with CRTP. You pass in the if you want to look at a proper example, we can look at like I don't know, probably any AST node in Clang is a better example, maybe, if a more complex example.
All right, we'll wait 20 minutes for...
Yeah, while that's starting, you can
Yeah.
take a look at the basic API if you go back to VS Code. So you inherit from trailing objects and you pass in all the things that you want to store as trailing data. You then have to tell it how many elements of each type of trailing data you have, so it knows how to get to the next one. And then in the when you allocate the things, so if you go to that's why there's a create function here, because just calling the constructor isn't going to work. You need to allocate more memory than the object size of the object. So if you go to the implementation of that,
if it'll find it,
that is basic block. Okay, go to statement.cc. Yeah. Probably.
Here's a built-in call we can use.
You can use this convenience function, which is total size to alloc, and you pass in how many of each type of trailing data you have. That gives you the size you need to allocate. Then you allocate that and you do a placement new into that location. And in the constructor, which is right above, you copy the elements into after the object. And then if we go back to the class, if you want to get them back out, you can do get trailing objects to get how many you have, a number here. So basically, you're storing all the extra data you need after the statement itself.
Okay.
That way you can get to it, even if it's not actually part of the struct. That also means that in Clang and in my implementation, you can't do things like add an element to a call expression.
Right.
Or an argument. You have to rebuild the entire call expression.
Yeah, which is fine.
Yeah, because you probably won't be adding elements too often.
Yeah.
And that way we can make it so that AST nodes don't have destructors. And in fact, in Clang, and I also do that, we static assert that none of them have destructors. Because that allows us to allocate them in an arena and free them all at once.
Right.
So that also means if you want to store anything in an AST node that requires a destructor, you need to actually store it somewhere else.
Yeah.
So that's why Clang has stuff like identifier info and declaration name. And that is the reasons why that exists, but all of that is to make it so that the memory is stored somewhere else. Qual type in Clang is just a type with qualifier, so that's the actual type is also stored somewhere else. And for things like, what was the other example? APInt and APFloat. APInt and APFloat may need destruction because APInt is however big you want it to be. Like you can do 1024 integer or something with it if you want to. I wouldn't recommend it, but you can. And for that, it needs to allocate extra memory. So Clang gets around that by actually storing the APInts in the AST context, which is where everything is stored basically. And then just storing a reference to it in the AST node, and that's what's stored in J is. So I think it's called something similar in Clang too.
So this is up. Do we want to look at anything in Clang?
I mean, you can go to like I don't know. What would be an example like? Literally anything like expcxx.h, whatever. I
don't remember how to open my file search here, actually. I can find in all files, and then if I did like, I don't want to do that though. Like F.
In that case, let's go to the file directly.
Yeah.
Should be in Clang include.
I mean,
okay, that's a solution that doesn't help. Can you switch to a file view? Good God, this program is slow. Okay, Clang include AST, Clang again, AST, expcxx, you have to scroll down a bit for that. And just something in here is probably going to have a lot of trailing data. It's also a huge file though, so
Trailing objects.
For like, I don't know. Yeah, there you go. This is a static cast expression that stores a base specifier and whatever FP options override is. It's probably for floating point nonsense. And it's apparently the parent class takes care of that, but you can find some more instances of us just still a bunch of trailing bits. You can still store more things than just one thing.
Lambda. A new expression.
And then the source range, for instance. So you can store more than one thing. As opposed to flexible array members in C, where you can only have one. Perhaps this one isn't the best, but here you have a few more things in there.
There's so many things. Give me a simpler one. So many unresolved.
Yeah,
regular new expression.
If you're looking for some more involved examples, you can find them in here. If you want a simple example, I think you can look at my code base, which does the exact same thing.
Yeah.
Basically. But yeah. That's the general idea of how we solve that problem of both storing extra data in a node and not requiring nodes to have a destructor.
So many packs. I made it to the bottom and none of them are good. But okay, it makes sense conceptually. You'll just have to know how to do it correctly.
Yeah.
So, God. And then, so we're still doing that at the.
Yeah, you can do that, or you can also just allocate them normally, but then you have to remember to delete them. It's however you want to do it.
It would probably make my brain hurt less if I didn't do the trailing objects thing, so I'll probably not do any of the storage then and just store the AP stuff directly. Because, I mean, I want this... The way that this is going, the compiler is going to live for longer than the C compiler would have. So I don't want it to be completely inefficient and stupid, but also it's a compiler. It'll be fine.
What you can then probably do is just store unique pointers to each of the nodes in the your equivalent of the AST context. Or just make sure that whenever you create a node, you store a pointer to it somewhere so you can delete it later. Is the main thing.
Yeah, because what we were doing in LCC was we had the operator new overload that stored a pointer to everything in its context, right?
So what?
When we were doing LCC last year, we overrode operator new to take in a module, so we could store in the syntax module a list of all nodes.
Yes.
Right.
That is still what I'm doing. Because, and what Clang also does, because it uses the bump pointer allocator of the context.
Right. Is there anything fancy about the bump pointer allocator I should know here for doing string allocations, like the integer
string allocations?
Thing?
We have something else you can use.
Like, because really all I need is something for string literals, right? A string builder, and then I guess I use a string. You've got a string storage thing somewhere, actually, now that I think about it.
Search for string saver in my code base.
Yeah. I have it as well because it came out of LLVM here. So I'm using it for the same string purpose. So I could just use a string saver.
Yeah, you can use the string saver, unique string saver difference is what you expect. The unique string saver just caches. So I would use the unique string saver maybe during parsing.
Yeah.
And then string saver later because you're unlikely to create too many repeated strings after parsing. During parsing, because you have the same variable 20,000 times. Sure. Yeah. But after that, no. So
then instead of whatever I've got here, I can just grab the string.
But also the string saver takes a bump pointer allocator as an argument.
So in my syntax module, then I can have the string thing here.
And make sure that if you want to be able to use the strings after that, the string saver has to live long enough, so you might have to move that out and into the module later.
Yeah, I was trying to figure out where I wanted to put these because, I mean, it doesn't matter. They're public, so I can very easily just grab them and move them when I do Sema, which is probably what's going to happen.
If they happen to be immovable, just drop them in a unique point and move them that way.
Yeah. Okay, so I assume then the bump allocator is one of the immovable ones if it's in a unique pointer, but we can find out. I have no idea.
It does seem to be movable.
Yep. Okay, so that's not why then. So then for string saver, can I inline reference the allocator here then?
Yep. Generally, yeah.
I have to like deref to get it back. Constructor. Okay. Let's just find out what constructors it has. Bump pointer allocator reference, which should have just worked, right?
That should have just worked, yeah.
Unique string saver for moving and a const for copying.
Copy and move, so it has a copy constructor, that's cursed, okay.
So it does work, and I just did something wrong, I guess. Sure. So then we can move these out if necessary. Okie dokie.
What I would do for string literals, I would actually just store the string content in the string literal and then do the interning when you code jump, then that's easier.
Okay, so just not even use the string saver?
You can use the string saver for creating them, because if you're going to do what I did and pass around my string class, you need to store them somewhere.
Right. Yeah, which is what the saver was for.
Because the point of that class is to make sure that both you don't have to copy anything because it's just a reference to a string, but also that the thing lives long enough. So that's why the reason I'm not randomly storing string refs everywhere because that's a bad idea.
Yeah. Right. So like for building strings in the Lexer, I'm likely to just use standard string and append to it.
Just use a standard string or an LVM small string or whatever, and then just save them somewhere.
Right. So I'll probably then just have a token contain string, which is your string wrapper.
I'm pretty sure what I did for tokens already does that. The token stream class I have or something.
Yeah, I haven't looked at your token stuff yet. Okay. I've been looking mostly at the actual utilities, so let's see what you have in token, I guess. As an AP integer, yeah. Location, a string text, yeah. Text that this token references, but yours doesn't necessarily say that it's the string literal text, but it might be.
Well, if it's a string literal, it is the string literal text. It depends on it. What this is depends on the token.
Gotcha. Right, because I've got a wrapper around the location right now, which makes sure you can get the spelling. I'll probably call it to be like Clang instead. So then string actual text can just exist. It has a default, it'll just be empty, right? Yeah.
Default is empty because the empty string is here. You can also the point of a string is that it's a string that quote unquote lives long enough. Yeah. So you can construct it from a string literal too, because a string literal is static, it lives long enough.
So those are LLVM prefix, that's right.
I would just import them somewhere, but yeah.
Yeah, I don't care as much. I like being explicit, you know me. So, what does it want now? Because it still needs these to be initialized, question mark? Did it not like that, or am I missing something? Well, apparently that's that. Can float value not be? AP float needs a constructor.
I do not know how to use AP. I've never used AP float.
Neither have I. It can take in float values, so sure. Do it to be a 0.
Oh, you need to probably give it the size because...
Yeah, because it doesn't know what to start with. So if I just give it a float value, it defaults to being a float. Cool. Then these, if I build, those errors will go away. So then that should be all I need for a token at the moment. Do you have... I feel like you had more in there. Location, True if it's EOF. No, the artificialness. Yeah, I should probably also have an artificial flag. That's a good idea.
That's mostly to escape things in macro expansion.
Depending on what I end up doing between parsing and sema, I might be inserting additional tokens to keep the syntax tree sensible. So it wouldn't hurt for me to have the concept of artificial. Right, like I think we talked about a few months ago my potential parsing issues or representation of. This is not the one I want. I want this one. Of like constructor syntax. Right, and I think at this point, yeah, constructor syntax doesn't have to have a token before it, just the open bracket works. So I might insert like the var token here just to have a token in place of the whatever here. I don't know. I don't know what I'll do. I probably won't, but I might. It'll just depend on what happens.
In Clang, we do that in some places. We replace or we insert things that we call annotation tokens.
Right.
It's used for things like, for instance, if you use OpenMP, OpenMP directives get turned into actual tokens, and then those get parsed.
Right. And for parser errors, I might generate the tokens that it complains about. So if you're missing a semicolon, I'm not going to do semicolon insertion, but I might say, hey, semicolon's missing, but I'm going to put it there for you anyway.
I would just skip it then, or we would just...
It depends on if I'm doing storage. I don't know... I don't know what I'm going to put into the syntax tree. Like I said, I want the public API to be something you could use for tooling, which might mean include tokens that are like, I mean, I wouldn't want to, I'd want to mark it as artificial so it's not like highlighted by a syntax highlighter, but they might want to know that there was supposed to be a token somewhere. I don't know. I don't know what's going to happen. I'm hypotheticaling here. Hypotheticals are hypothetical for a reason. I don't know. I don't want to overcomplicate it, but I got to think about these things. Okie dokie. So I've been doing this for 2 hours already, and I have not even started the Lexer. All of this was, let's start the Lexer, and I'm 2 hours into not starting the Lexer.
Usually, yep.
Yeah. I've got the constructor giving me the current and end pointer, and everything else has been not in the Lexer. I mean, I've got it to the point where if I run it, it'll tell me that I need to implement read token. So we're all the way up to the Lexer.
That's nice.
But the rest has been API work around the Lexer. I don't think I need to have made the Lexer a p-impl, but I did.
I think...
Doesn't really matter.
For me, the Lexer is just... Where do I have the Lexer?
Your Lexer is like completely private. You don't have it in the public API at all. I still want people to be able to grab tokens, so I put it in the public API with a read token function.
For me, what I have it, I do have that, but it's on the parser.
Yeah, yours has just a Lex only flag, which I don't disagree with, but I didn't. It's not what I'm used to doing, so I just didn't do it.
But the point is, if you want all the tokens, you get a token stream, and I also Lex all the tokens beforehand.
Right. Well, I have a read tokens thing to do that as well. If I want your version of the API, I just call read tokens into a module, and it'll store the tokens. If somebody wants to read token by token, they construct the Lexer manually themselves and call the read token function. So I wanted a public API, so I changed the way it was working slightly. That's what mine's going to look like.
By the way that this Diags producer thing works, did you change that to use CRTP or something, or?
It should, yeah, I copied this one and I forgot to change this. Boom. I haven't put in the actual diag call yet, but nothing's calling it, so it's not gonna error until I do, but I'll have to go copy that. It'll come through context diagnostics.
That template parameter was there before is what's returned from those functions. So
currently it's void by default, which is fine. Yeah, I would have gotten the error as soon as I tried to use it. That one I would have understood. I've looked into, I know what this does. We talked about it. I'm plenty familiar with. I have used it already in the driver, so I can copy the stuff from the driver if I need to. I'll get there when I get there. too many new things in my brain. I just got to do the things I'm familiar with. I could use... So string saver, question mark, does copy the data from a string I give it?
Yes.
Okay, so it's not a huge saver, but I could say std string builder in my lexer, build a string into it and then clear it after saving.
Sure, you can also do, if you want to have an even larger buffer, you can use an LVM small string and do like, I don't know, 128 characters or whatever.
Std, so...
That's just like small vector, but the type is always char.
Small string, string builder, like that. Beautiful. Cool. Cool. Now I've still got to do all this stuff for getting location information out of here.
I will be right back. So.
Okie dokie. So I guess I'm more curious now. What's in location as far as operators go? I love how long it takes for IntelliSense to keep up. How much do I need now? So now, it doesn't like this. So this is an int32, which needs to be an int16, which is annoying, but okay.
I mean, if you in C++, I would do a C++ style functional cast instead of a C style cast.
And then I assume that this means the first one is also wrong. Do I have to cast this pointer arith to a U32?
If you're using braced initializers, those stop implicit conversions, so you have to do them explicitly.
Okay. But this. Oh, yeah, so let's just do location.
No, that's not the problem. What you're doing is you're casting...
Oh, it's a uint. Yeah, but
wrong type,
it's not going to matter then. It's going to have to require the cast anyway. If it needs the cast anyway...
Also, what I typically just use is U32 and U16 because U in 32T is a mouthful.
Oh yeah, I know you do, and I've changed them all back.
Hmm.
It is a mouthful, and I would love to use U32, don't get me wrong. I just, meh. I didn't want to put it somewhere. I didn't grab it. I didn't set it up. I had already started writing with these, and then I just blech. For
There's a
consistency.
very simple way of doing it.
I know there probably is. Put it in my module.
Yeah.
If I just say
Put
fucking...
in your utils module or whatever that is.
Just in the export namespace as well, just do a using or something.
Yes.
Boom, I did it.
Mm-hmm. I have all of them somewhere if you want to copy them. I think it's in base utils, not in here. There. That even does eye size properly. Look at that.
Neat. I'll see if I want to start using them. I just wasn't using them before. See if they show up here if I do uint and...
It's wondering, the proper way to do it in C++ without typos would actually be standard : U in 32T, as you can see here, which is what no one should want to do, because that's horrid.
Cool. I might change some back then. But... Oh boy, tired. Location began. So then I have a... Let's call it ELF. Return. How the heck did I get there? Return greater or equal to n. It needs to be fucking cool. So I guess I can do it though. The question is, do I care about... I don't think I do. I think this is fine. So I can grab location, start location. That's fine. Then we can do... I'll want a skip white space. That's for sure. Auto skip white space.
Probably a good idea.
Be a void for now, but I'll want to sometime soon. Maybe I do it right now. Store my white space. Comments at least need to be stored. I can definitely do comments.
You can do what Clang does. We have a different lexing mode where we keep the comments and by default we ignore them. Which is what I would probably do, because for actual code you probably don't want your comments, but for generating documentation you do.
Yeah,
so
what I am used to doing is C#'s method of generating trivia and storing them as prefixes and suffixes to a token, but that is kind of annoying if you're doing single token parse where you don't intend to keep the token around, I guess. It's not like that big a deal. It's just like, what the heck do I do?
I would just keep all the tokens around them because it's easier to look ahead that way.
Correct.
Like lex all of them ahead of time.
Yeah. Which is the default thing that the parser is going to do. The parser is getting all the tokens all at once.
Mm-hmm.
Since I'm providing a read single token API, though, I have to think about it. And right, because like what I'm referring to would be the equivalent of std vector, or at least I guess it could be an array instead of a vector, but something that I need to destructor and dynamic allocate stuff.
Mm-hmm. I mean, this class already has dynamic allocations.
That's true. So if I std vector for now, but it wanted to be a small vector, so LLVM.
Probably a small vector, so you can store them inline. Though to be fair, Most tokens aren't going to have one.
Most aren't, and most that do are going to have a small number. If I do all trivia, then they have a handful because it would include white space. If it's just comments, it's going to be like maybe one or two, one before, one after.
It's just that if most tokens are going to have 0, I would probably honestly just use a small vector with inline size 0 or something, because otherwise every token you have is just huge, even though it's all empty.
Right, so this is how I'm used to doing things. I don't use it very well most of the time, but when I try to, that's how I do it. So then I would have...
Again, a lot of what I also saw a thing talk by, who was it? I think Chandler on the Peru a while back, about how in LLVM, a lot of what we do is just about compressing stuff in memory.
Yeah.
So we can iterate over it faster. So we have a bunch of things for that small vector, tiny pointer vector that you saw earlier that stores either 0 or 1 pointer.
Yeah. So then if I wanted to do trivia for white space, I can have like multiple trivia modes. I can have comments only, comments in white space, and none, probably. So I could have white space, line comment, block comment, a doc comment eventually if I want to have a specific thing for documentation comments to be recognized separately from block comments. I don't know. Something. That's the kind of what a trivia is. And then you stick it on a token, and when you're parsing a declaration, you find all of the relevant tokens that have trivia and try to construct something out of them. But
I'd honestly worry about that later once you have... I mean, I'd implement what you have, what you need for the parser, and then worry about extra stuff later.
Right.
Otherwise, we try to implement every feature now.
Oh yeah, no, not every feature, but trivia is something that's trivial to do because just instead of discarding the tokens, I store them in the string. Or not the tokens, the characters. If I'm reading a line comment, instead of just skip, I append to the string builder here. That's the only difference. So it's not a huge change, especially if I've already done half the work by just defining it. So I might still go ahead and do it. Usually the only complication is that you want to split leading and trailing trivia on new lines. So reading trivia all the way up to the next valid token character works, but then trailing trivia only reads to the next character or end of line, which is also just like a 2-line thing. Like, it's still not that complicated. So that does mean I will want to have like an enum struct syntax trivia mode that we can select from. I'll just put that here. None, comments only, documentation only, comments only. If I go all in that order, only doc comments, all comments but no white space, everything. And those can be the 4 modes that we lex in. So when we construct a lexer here, we can include that. I like a preamble. So source file, trivia mode is none by default. And we can do that into read tokens. Whenever I save this file, if I save it like twice, it decides that, no, you can't save it again, you have to do something else, which is annoying. So then here, when I'm constructing, we can pass in our trivia mode. So then it's part of my API, and I can build it. Because it looks like IntelliSense is behind, and I need to know if I fucked up. Because this also needs syntax trivia mode to go to the preamble. Which then needs to take my syntax trivia mode, trivia mode and be initialized. It needs to be technically for my brain to not hate it in order. Okay. Now we can double check that it builds. Cool. And we should still make it to the please read the Lexer character token. Cool. I do have it, like I said, the driver already handles diagnostics the way that you've got your mixin working here. So I've got color diagnostics. I can set color equals never, I think is the thing. So that, like I've got all that configured already.
Nice.
Not that it was difficult, just that Visual Studio doesn't like it because of the fucking IntelliSense errors.
Yeah, because
this one's even worse than the last one.
Yep.
I haven't done the is a TTY for default yet.
The entire string literal is just part of the template, so
Yep. Yeah.
the longer that options type get, the longer the error messages get.
Oh, I should look at help. Does help look pretty? You said you made help pretty. Have I reconfigured?
They're sorted now.
Supported option values, color, options, file. Cool. Yeah, so I'm up to date enough that I have arguments. File, color. Neat.
Because what I'm doing for this is I'm sorting them at compile time because the help message is generated at compile time.
Yep. It's very cool. Dockily. Alright, back out of here. Back into skip white space is going to read consume trivia probably into our small vector of trivia. So we'll want to take a reference or the token itself, but a reference so I don't have to choose. Small vector syntax trivia. It probably doesn't matter. Is there So if I wanted to pass any small vector, no matter what its initial size was...
Yes. The way you're supposed to do that is you're supposed to pass a small vector impl by reference.
Okay. So a small vector impl of syntax trivia by reference.
Yeah.
Trivia. So consume trivia into this vector.
You don't want to pass a small vector by reference as a parameter. You just want to pass a small vector impl because that way you don't have to hard code the size. That's if you want to modify it. If you just want to access the elements, pass an array ref. If you want to mutate them, you can pass a mutable array ref. But if you need to append or delete, you need to pass a small vector impl by reference.
By reference. So I still need the reference. Yep. Then I want bool is trailing.
Small vector impl is an abstract class, so you can't instantiate it directly.
Okay, so is trailing, so we can stop on new lines. So this whole thing will come down. Really, I kind of want to put this here. So I'll put this here. Consume trivia. So this will do all of my white space handling. This is a Lexer impl. And I think my, Lexer impl is also a diax producer, so I need to go grab my two helper functions and context.
You only need one because it's generally the point of it. Oh, you need two because at the current location.
Yeah.
Sure.
So this, instead of being this, can be this because I have a location macro, or not macro, function that doesn't exist yet. So fucking just in case, put that there.
No, that's fine. It's fine
because it'll be expanded later. But
yeah, the way it works is that it first, quote unquote, it reads the entire class and records declarations. But certain things are only passed once the entire class has been read, so at the closing brace. And those are member initializers, so if you do current equals whatever, in the struct member, default arguments of functions, as well as member function bodies. Those are only passed once the entire class has been read, and that way you can have forward references.
Alrighty. Then. Then. That's fine. Okay, so then for consuming trivia and for reading tokens, so the thing at this point then, so I was gonna say I can just not create a syntax token here, and I might still not, depending. Because I don't, for some reason, I just don't like pre-allocating the syntax token that I'm going to return and then mutating it throughout the token reading process. But if I'm consuming trivia into a vector, I need to, at the very least, have the vector available. So either I pre-allocate the token, or I only pre-allocate the trivia vectors.
I would just pre-allocate the token.
Yeah.
Directly where it's going to go in the end. Like if you have some vector tokens that you're trying to store. Or you could do that, sure. That also works. Because that's going to align the move the way you did it there. So.
So we need to I guess at this point token.location can just be location, so I don't have to do this. We don't have a kind for it yet. So like I did that whole constructor under the assumption that I'd probably just do that. But if I'm not going to do that, then I can just default initialize explicitly because I like that. And then I don't need to do that either. And I just have a token. So token, whatever, location. Likes that, that's good. Its kind is invalid, so then we want to consume trivia. Leading trivia will be into token.leading trivia. And it'll be is trailing is false, it's leading. Then before we return the token, we return or we flex all of the trailing trivia. Like that. Okay. Then I need to if EOF, that's what I'm forgetting. If EOF, we're going to return the token. We're at the end of file, there's no trailing trivia. Token kind is token. Syntax token kind. If we just select the correct one, EOF. Is that what I called it? End of file?
I think it's all caps EOF.
That's why. Because I didn't do a second colon on accident.
Oh, and you're using MSVC, which doesn't, yeah. Because what we do in Clang is typically we autocorrect colon to colon. In most cases, except for like after a case or a label, maybe. So,
yep, didn't happen here.
Yeah.
Okay, so that's all I have to do for EOF. We've consumed its leading trivia, which means, boom, we have an EOF token. Then, at this point, we should have a valid token character or the error, so switch on current, which is this. In the default case, which is easy enough to handle, we will error by default, like, if nothing happens. If we don't have any valid character, we want to say valid character source file at the current location, which is fine. If it's an invalid character, then I'm trying to think of what kind of error messages I'd want to report for invalid characters now that we're including trivia in tokens. So if I have leading trivia, invalid character, but then the next character starts a valid token, do I just want to skip invalid characters and associate the previous trivia with valid token? Maybe. But then I'd have to hop around in this function. My solution would be to use goto, and then the entire programming world would yell at me. So maybe I don't do that. Maybe we just consider it an invalid token like normal. Say fuck it. So error invalid character in my source file, which leaves the token kind at invalid by default, but just to be explicit, invalid in case it changed beforehand. Token kind is invalid. Invalid source break. Okay. So now, rather than getting an assert in the lexer, I would just end up with an error for every single character in the source file, except, oh, I'm not advancing, I need to include an advance, which could just be fucking current plus plus, but I like to have a function for it, so auto advance. Oh, because it's const? It's const in the, oh, because I'm const. That's not what I wanted. That doesn't make sense. Then we advance past the bad. The ID is the absolute, yeah, no, this, I don't like Viz, don't get me wrong. I'm using it out of necessity. Also, hi, welcome, Mugame, how you do? Now we can build. Succeeded, cool. So then if we go back to test.lya and do yield ASDF, so I don't get 5 billion errors. ASD and F are all nice and pretty printed, that's great, we love it. We do good, that's good. So now actually parsing our tokens. We haven't done any trivia yet, but there is no trivia in the source file, so that is fine. Hoy, I am due tired. I am due have been stream for 2.5 hours and only just barely now started the lexer. So I might just call it for a little while, go do some video games or read a book and come back. I know you just got here, but brain. We can at least start the trivia parser maybe. While not EOF, we have some things to do. We can say car C equals current, so we can do a bunch of tests on it. We might do switch on C. I've been lurking a little longer. Oh, okay. Didn't even come say hi. Can't believe it. Out of water. That'll definitely be on my to-do list. I need functions for if something is white space, etc. I normally make those global. I can do that not terribly with modules. I could do free functions. Tired, God. To just ask if a character is a given thing. Oh yeah. Right, like I might just do is white space. And we can worry about Unicode later.
Outside of Alexa?
For public API and potential tooling,
Mm-hmm.
I could put it as a static function on the lexer, but asking the lexer if something is white space feels weird. It's just like a fact of the language as a whole, so I don't know where to put it otherwise.
We do have a few utilities for that. I think we have like LVM is space and is alpha somewhere.
Yeah, I like having specifically Laya is whatever, so you can ask not just if it's a white space character for a text document, but does Laya consider it? So just even if it's as trivial as calling LLVMs for now, the semantic difference is I'm explicitly asking the Laya library. So is white space. Again, eventually I'll have to think about larger characters, like if we're doing Unicode identifiers, but like for now, we're just gonna fucking worry about ASCII because I don't give a shit. Start and continue. Continue is decimal digit is digit in radix probably, or in base, but I always just call it radix because fuck you. And those are the big 5. Don't really need anything else. So I can still implement them in Lexer, no problem. But so I don't have access to it, whatever it is. Where is support, probably? Character ranges would do it, probably. Do you know what header you were referring to for the LLVM stuff?
String utils, I believe it's called, or something.
Makes sense. I'll want the Unicode code ranges eventually, probably, so I'll leave that as a reminder. Extras, string extras. That's in string extras. So for right now, this is going to return C is greater or equal to A, and C is less equal to Z, or yes, C is greater or equal to A.
I think we also have is alpha.
That's I don't even know why I didn't even think to look at this. Alpha is alnum is correct because Lya does that. Does alnum include underscore?
No, because that's not a
Not
number.
alpha. Okay, good. Or C is equal to underscore. Is identified and continue is the exact same.
Also, fun fact, because we're already in the subject, in case anyone's interested, I would recommend not using standard is space and all of those functions, because they have a few quirks. For instance, if the thing you pass in, they take ints, but if the value that you pass in doesn't fit into an unsigned char, it's undefined behavior. That's already great. But the thing is also that they are also slower from what I recall because they never get inline because they're defined somewhere internally. Whereas if you just define is space yourself, the compiler will do a pretty good job of optimizing it in a rather ingenious manner typically to where it's even branchless. There's a very cute thing you can do because it just so happens that all the white space characters that you typically care about except for space are adjacent in the ASCII character range. Instead of checking every one, you can just do a range check. And the compiler can't do that if is space is defined somewhere else. Maybe you have a pass in the backend that does that, but from what I saw, no. So just defining those yourself is typically a good idea. And that's probably why we have them in LVM. I think they have it for at least hexadecimal, but I'm not sure we have a generic
They do,
one.
yeah, I need a generic one for bases 2 to 36.
I recall seeing something about that. It might be in... I think we can pass numbers for up to base 36. On stringref there's a function that does that, or somewhere on APN. But I'm not sure if there's a function that can validate them.
Yeah, for now, I'm just going to worry about parsing regular ass numbers, and I'll do my my super duper fancy number-based numbers later. Just want to remember to have them. So these need to have the Lya, because they're not type name before them, so they have to be explicitly put into the namespace, I believe, for it to find them. There it is. Cool. So then we can do ye old simple if is white space C. Then we have a couple of things we can do here. If my trivia node is equal to all, then we do a thing. If it's not, then we just while current is white space, while not EOF current is white space. Advance. Otherwise, we want to actually append all of these characters to the string builder and store it, which I'm just going to acquire to do trivia storage. Oakley dokley. So then I should be able to put white space in here. Okay, so if that's should only report invalid character on. It's not happy. It's going forever. Why not? Probably from the trailing trivia, question mark, but it should be fine. Let me, just in case, remove trailing trivia and try again. No, that doesn't do it. Oh, because this needs to break as well. Else break. Duh. And that doesn't need to be a whole last block. It needs to be that. Always break your loops.
Mm-hmm.
Okay.
I mean, oh yeah, because you might not get to end the file. It's
Yep.
true, yeah.
You might get to an actual token. So this should report ASDF FOO. Cool, but it's not reporting on any of the white space. It is successfully parsed, ideally, the leading and trailing portions of the trivia, because we're not caring about leading and trailing right now.
But you look how this is currently doing the opposite of what an actual Lexa typically does. It passes all the white space, but just screams at you for anything else.
Yeah, it's great. Yeah, it's exactly what you want. Where is everything that I need? Good, well now I know where it is. Don't know what it is. So what we care about for is trailing is if it's a trailing white space, or if it's a trailing trivia, and current, if not, this is not the best way to do this, but I just want to get the thought out of my head. And current is a new line. Well, we want the previous one to have been a new line. If we're past a new line, we want to stop. So while all of this, we want to consume the new line if it's a new line. So I'm going to say car P equals current, then I can just say if P is a new line. I'll figure out a way to make this not look like shit later, but if P is this and it's trailing and it's not at the end of file, we break. Well, if it doesn't matter. If it's EL file, it's going to break anyway. So if it's trailing and the previous character was a new line, break. So I don't do this funky nonsense. This should still work. It should not change anything. But, and really, if we're not doing trivia anyway, then it doesn't matter if it's white space or not. So fuck it. We're not even going to do that. We're just going to advance. Yeah, it didn't do anything. So, I mean, it's the same thing. There's all of our shit. Cool. We can do comments. So if it's white space, that's a thing. Else, if I'll need a peak. So we can do if C is equal to slash and peak is equal to slash advance. So let's just grab an auto peak. Column peak is const. If current plus 1 is greater than or equal to and return fucking 0. Return current plus 1. So if these two, advance, and then while, again, we can grab trivia mode here. We want to skip past this for the text purposes. So we want to grab location and start location for all of our trivia anyway, even if we're not using it yet. So if it's all, I should probably do this as just a regular s like greater than or equal to check. But then I have to change the, you had a thing for treating enum structs as integers somewhere. Is that in source still, or do I?
Yes, it should.
Okay. In this case, I don't know if I care, but I might, I guess. Let's just go find out.
Enum support greater than or equal though.
Well, enum struct.
Yeah, think so. Not just do greater than or equal. Yeah.
So if I do greater than or equal to comments only? Question mark.
I think that should work.
I didn't actually want to run it, but that's fine.
Mm-hmm.
Looks like it worked.
Mm-hmm.
Okay, interesting. Need not to
There's
know.
somewhere between strong type defs for numbers and actual numbers. Like I don't think you can add two together.
Right. So while this,
or all of them together by default, but you can just compile them. That's fine. They are ordered, so. That's a better way of putting them. Of putting it that ordered. They're just not numbers.
Yeah.
Not by default, at least not.
Oh, hi, hello. Welcome, welcome. We're doing the opposite of lexing. So that should give me comments. Again, it's not really going to... Now that I've done white space... Yeah, no, so if I put in a comment, it should skip right past the comment, and we shouldn't see it either. This is a comment. It's valid. I clicked on the button. I didn't want to click on this button. Nope. Too many errors emitted. So it did not do the thing. It did skip over the slash and the slash and the white space.
That's nice. Also, I will have to go now because I have to go get groceries and do some other stuff.
Have fun. I should go get food.
If you need something, feel free to ping me. So
Will do. At the moment, I just need Lexer stuff, which I've done 50 times in my life before, so...
That makes sense.
Yeah,
so,
I'll be fine. Okay, have fun. He's gone. I don't know if I don't have notification sounds. He could have been gone for a while. Okally dokally. So if it's not EOF and it's not new line, advance. Cool. So now we can go back. Did I rebuild? I don't know. Cool. So now we're reading the line comment just fine. I'll probably say fuck it and not do block comments for the time being, and just these are the two that are the most important to get working. So it's easy for me to write code. So we've consumed all of our leading and trailing trivia. We're about to get to the point of identifiers and shit. God damn. I need to get up and but if I go take a 5-minute break, that's not going to be enough. I might need to go for a little while. I'm trying to convince myself to stand up is the problem. The longer I sit here, the less I have to move, but the more I need to move. I'm saying, everything sucks. I'll probably take a break here and maybe come back later today. If not, similar time tomorrow. I need to go try to talk to people about job stuff too. So I didn't realize I'd be streaming for 3 hours today. We've started the Lexer. The compiler project is available on GitHub. Let me make sure I didn't put anything stupid in here, like test LL. Everything else looks fine. I can probably remove the stored integer and float actually, but I'll do that later. Begin working on Lexer. And And currently it's under a different branch, so maybe I merge it into the correct branch and then go pull that down. So if I kill Viz so it doesn't yell at me while I do that, and I go off to places I'm logged into and compare and pull request into main. Verify. We can do dev with modules. Create the pull request. Okay, merge, confirm. Okay, so then if I go to choir main, this should have a fuck ton of things in it. It does, just now. So then I can git checkout main, git fetch, git pull, git status, up to date on origin main, git branch should show me module test. Is attack R to, what is the delete a branch flag? Is it D? I don't want to open it in Firefox, but I guess I will. Attack D, I just wanted it in the browser. Will be deleted, yeah. Git branch D module tests. Okay. That's all I needed. If I go back to choir, main, branches, I just want to delete the module test branch here too. Delete. Delete. Couldn't be deleted because I already deleted it. That's good. Code, main, main. Beautiful. We're on main. So if anybody wants, the project is up at hello. You picked a bad time to say hello. I'm about to go take a break. Maybe I'll be back later today. I gotta go do job hunting because I need a job. I need to go eat. I need to go try to exercise or something because my body hurts. If you aren't already and you're watching and you want to know when I'm going to go live, you can join the Discord in the description. I post every time I go live. We do lots of programming talking. I'm going to go try to take care of myself and not feel like shit. Thanks for joining. I'm going to keep working on this compiler because it's going to be fun. Hopefully, I want my brain to work. Brain working is fun. Yeah.